Okay, so today's lesson is about angles of any magnitude, but specifically when dealing with radians. So our learning intention is the skill in using the knowledge of angles of any magnitude using radians. And we'll be successful if we can correctly calculate exact values using radians. So let's look back at the unit circle. If our x-axis is cos of x and our y-axis is sine y, we get 4 quadrants. Now, remember, in all stations is central. In the first quadrant, all trig functions are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. So, in radians, obviously, we're going to start at 0, and 180 degrees becomes pi, and 360 degrees becomes 2 pi. If we want to convert degrees into radians, we multiply that by the degrees times pi over 180. And if we're going from radians to degrees, we times it by 180 over pi. Okay, so if half of a circle is pi, half of that, or 90 degrees, is pi on 2, and a quarter of that is pi on 4. Okay, so we've got 0, pi on 4, pi on 2, 3 pi on 4, and pi. And then obviously moving to the the third and fourth quadrant, we get 5 pi on 4, 3 pi on 2, 7 pi on 4, back to 2 pi. Now, if we're going negative, we're doing negative values, this will be negative pi on 4, negative pi on 2, negative 3 pi on 4. Okay. So that means in this quadrant, it's just the degrees. Here we get pi minus theta. On this side, we'll get pi plus theta. And in this quadrant, we'll get 2 pi minus theta. Using our exact triangles, if we had an isosceles right angle triangle, so a unit of 1 and 1, would make the hypotenuse square root 2 using Pythagoras' theorem. And if it's obviously an isosceles triangle, the base angles will be the same. So if that was a 90, both the base angles will be 45, which is pi on 4. Alternatively, if we had the other right angle triangle, which is half of a equilateral triangle, so an equilateral triangle of 2 units, if we halve it, would only be 1 unit. So this height would be square root 3 using Pythagoras. The base angles are 60, so convert that into radians. 60 times 100, pi over 180 becomes pi over 3, and 30 degrees becomes pi on 6. Okay, let's do some examples. Alright, we want to find the exact value of sec pi on 6. So pi on 6 is 30 degrees. So we're going to use our exact triangles. And sec is the reciprocal of 1 over cos theta. Okay, so that then means that cos was adjacent over hypotenuse, so we swap that around, so it's going to be hypotenuse over adjacent. And using our exact triangles, so we want pi on 6, we want the hypotenuse over the adjacent, so it's going to be 2 over root 3. Okay. So our next example, we have sine of pi over 3 over cos pi over 3. Well, one of the identities, if you have sine theta over cos theta, that's equal to tan theta. And at the moment, tan theta is pi on 3. Okay, so looking back at our exact triangles, we want tan of pi on 3, so we want opposite over adjacent, so that's square root 3 over 1. So the solution will be square root 3. Okay, so we want now 1 minus cos squared of pi over 4. So that's going to be 1. Using our exact triangles, we've got cos pi on 4. So cos pi on 4, so that's adjacent over hypotenuse. So we've got 1 over square root 2. Now I'm going to use the identity instead. So rather than doing that, I'm going to use the identity. So I know that sine squared theta plus cos squared theta equals 1. And if that was rearranged, you then get cos squared theta equals 1 minus sine squared theta. Okay, sorry, not that one. I'm going to have sine squared theta equals 1 minus cos squared theta. Okay, so this whole thing just is going to be sine squared on pi over 4. Okay, so using pi on 4, sine is opposite over adjacent, so that's 1 over square root 2. And if I square that, I will get a half. Okay. Alright, we want to show that 7 pi over 4 equals 2 pi minus pi on 4. So I can do that by stating, if I had so if I could do 8 pi minus pi, that would be 7 pi. So that's the same as 8 pi on 4 minus pi on 4, which is the same as, simplifying that, it's going to be 2 pi minus pi on 4. So 7 pi on 4 is the same as that, and I've shown that equals the same as 2 pi minus pi on 4. So if I want to then calculate 7 pi on 4, I think of it this way. There's my quadrants. Okay, this is my 2 pi. So I'm thinking of doing a full revolution and then coming back pi on 4. Okay, and there is my right angle triangle. And so if I want to figure out cos, 1 unit square root 2. Yeah, cos is positive in this quadrant, and so I want adjacent over hypotenuse. So cos 7 pi on 4 is equal to 1 over square root 2. Alright, if we want to find the exact value of 7 pi on 3, so that is very similar. So I can think of that as tan 6 pi on 3 plus pi on 3. Yep. In the sense of that's going to be tan 2 pi plus pi on 3. Yep. So there's my quadrants. I would go all the way around to 2 pi, and I'm adding pi on 3. Yeah. Make my triangle. So pi on 3, we have 1 and 2 and root 3. So if I want tan, I want opposite over adjacent. So that value for that is going to be root 3. Okay. So this I can think of it as tan. I've got 18 pi on 6 plus pi on 6, which means I get 3 pi plus pi on 6. If I draw my Cartesian plane, 4 revolutions 2 pi plus an extra part, extra half, that's 3 pi, and then I'm going to add pi on 6. So using my exact triangles, I get that to be 1, I get this to be 2, and that root 3. Tan is positive in the third quadrant, all stations 2 central. Yeah, tan is positive in the third quadrant. So if I want opposite over adjacent, I get 1 over root 3. Okay, so thinking of this one, I can think of it as sine. I think it's 3 pi on 3 plus pi on 3. Yep. 9 pi on 3 plus pi on 3. So that would be sine 3 pi plus pi on 3. So once again, 4 revolutions 2 pi, another half is pi, so that's 3 pi, and then we're going to add pi on 3. Okay, so pi on 3 we get 1, 2 root 3, and that using our exact triangles. Sine is negative in this quadrant, so it's going to be negative. So we want sine, we want opposite over adjacent, so it's going to be negative root 3 over 2, and that's the solution. Okay, that's it. Thank you very much.